Hey kiddos, I just wanted to review what we worked on this morning with kind of an understanding of an array and how that transfers into an area model, and how those two ideas also then lend into the understanding of the distributive property. So we're going to start with a problem like 28 divided by 2. And we're trying to figure out how many groups of 2 would it take to get us to 28. So over here, I'm going to say that, well, I'm going to have to put these in groups of 2. So there's a group of 2. And I'm going to keep doing this, keeping with my groups of 2 until I get to 28. Okay, so there's one group, 2, 3, 4 groups of 2 so far. You can see group, 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 group. So I'm dividing them into groups of 2 all the way across. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I have 28 dots there, and they are in groups of 2. So how many groups of 2 did I make? Well, I can literally count that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 groups of 2. Okay, that is your basically array. And how an array turns then into what we visualize as an area model, we know again that we have 28 and we're dividing that into 2. So we're going to have a side length of 2. And in here, instead of drawing 28 little dots, I'm just going to say, well, I have 28 in here. Okay, so what I need to figure out is what this missing side length is up here that would make it so I ended up with separating those 28 into groups of 2. Now, 28 is a little tricky to work with a 2, but if I look at the 28, I can see that I have 2 10s and 8 1s. So I'm going to try this. I'm going to say, okay, I have 2. And if I did my 10s, which there's 2 10s, so that's 20 in one space or area, and then put my 1s over here as 8 1s, I have 28, 28, 28, same, right? But now I have something a little bit easier to work with. If I were working with this same idea in my array, maybe what I want to do is count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 groups of 2. Okay, and so inside of that I have 20, just like I do here, which means I went over 10. So I know that this side length right there is 10. Now what I have left is 8 1s. Same here. 1, 2, 3, 4, 5, 6, 7, 8. So in this space I have 8 1s. In this space I have 8 1s. Well, if I divided them into 2s, 8 divided into 2 is 2, 3, 4. Okay, this was 10. That's 4. This is 10. That's 4. Literally what you're thinking is, if I have 20 and I divide that into groups of 2, I get 10. And if I have 8 and I divide that into groups of 2, that will give me 4 groups. See, 1, 2, 3, 4. Okay, And this is really great how this is going to take us right into the distributive property, because what you're doing in the distributive property is you're taking 28 and you're distributing some of it into smaller workable numbers. So in this case, we took 28 and we took the 20. So if we had 28 to start with, we said, well, 28 is made up of, we're distributing, that would be 20 and 8, okay? But always, we need to know we're dividing that into groups of 2. Okay, so what we have here is the number representation of everything we've been doing, but now we're just doing it with digits. And all we have to do then is solve that. 20 divided by 2 is 10, and 8 divided by 2 is 4, so we get 14. Here we got 14. Up here we did 10 and 4, we've got 14. Okay, now so what we're thinking right now is that 28 divided by 2 is 14. We decided that if we took 28 and we divided that into groups of 2, we'd make 14 groups. So if we're going to make 14 groups of 2, we should get 28. And this is how we're going to check our work. We're going to check it with multiplication. So 2 times 4, 2 ones times 4 ones is 8 ones. So we put that in the ones place. 2 groups of 110 is 2 tens. So we put 2 in the tens place and we get 28. So we know then that not only is 28 divided by 2 14, we also know that 14 times 2 is 28. Okay. Sometimes when I read a sentence like this, I always think in my head to read it backwards and go, okay, well, 14 groups of 2, is that 28? And if it is, then I know I'm right. I can show you a pretty good example of that if I did a basic division, like 4 divided by 2. Okay, if you had 4 and you divided that into 2 groups, we have this as a basic fact, so we know it's 2. Now, do you see that you can do 2 times 2, and that gives you 4? That's called inverse operation. Okay, so let's try another one. We'll have a little bit bigger of a number this time. This time we're going to take 84, and we're going to divide that by 7. So how many groups of 7 can we make to get to 84? So no matter what, I know that I need to be breaking this into groups of 7. Okay, so I'm going to make a group of 7. Here's 1, 2, 3, 4, 5, 6, 7. So there's one group. So that's 7, right? And 84 is really big, so I know it's going to take quite a few 7s. In fact, if I sort of think ahead, I think it's going to take at least 10 7s, okay? Because 8 in the 10s, yeah. So I know that I'm going to go over at least 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I fill all this in with there's my second group of 7, my third groups of 7, fourth group of 7, fifth group of 7, sixth group of 7, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. Oh goodness, see why we slowly are going to start going to area models and then even just taking that background knowledge and understanding numbers a little bit more to where we don't have to draw these pictures out. But there I have one group of 7, 2 groups, 3, 4, 5, 6, 7, 8, 9, 10 groups of 7. Okay, area model, 7 times 10, 7 groups of 10. That, in that space right there that I just created, is 70. Okay, now there's 70 in here. I can count them, but I just know that. So, but I haven't done all 84. I've only taken 70 of the 84. So I need to figure out, again, how many more groups of 7 I need to add to that to get to 84. So I know there's another group of 7. So that hits, that plus this would be 77. I'm still not there. 78, 79, 80, 81, 82, 83, 84. Okay, so I had to make 2 more groups of 7. There's 2 there to get to 84. And in 2 groups of 7, that is 14. So I know there's 14 there. So in here, there's 84. I divided it by 7. I was able to make 10 groups and 2 groups, okay, of 7. So I think right now that my answer is going to be 12 because I made 10 groups of 7 and 2 groups of 7 to get to 84. So right now, with my array, I think that it's 12. Now, if I turned this into an area model, I'm going to do the same exact thing, except I'm not going to draw those dots. So I still have a side length of 7 because that's what I'm dividing by. And in the space that I'm creating, I know there's 84 imaginary dots. 84, again, is kind of tricky to play with, so I'm going to start off small. And I'm going to think in my head some basic facts of multiples of 7. And again, I'm thinking in my head, well, 7 times 10, that's 70. 7 times 20, woo, that's 140, so that's way too big. But I can take out 10. So I'm going to take out 10 sevens, and that is going to be 70. That doesn't quite get me to 84. So if I thought about, I had 84, I've used 70 so far, that leaves me with 14. Okay, so 14's here. That's what's my leftover. So how many 7s would make 14? Well, 2. So this missing side length, again, is 12. Okay, now when you go to the distributive property, you're just kind of taking that next step in your journey. You have 84. You are dividing by 7. Think about 84 and how many 7s you could take out of there. And if you want, you can just like not even look at the ones place and just look at the tens place and think, well, I have 80. Well, I can't do 7 times anything to get 80, but that I know of off the top of my head. But I do know a pretty easy one where I could do 70 and divide that by 7. That would take a bit off my hands. I can definitely take that out. I can't go over 84 because that wouldn't work because I only have 84 to divide by. And 84, what would be left? Oh yeah, we did that over here. 84 minus that 70, we have 14. So 14 divided by 7 is going to be my other part. This is your distributive property, where you distribute the 84 into parts and divide those parts by your divisor. So here we go. We can solve those. This is 10. This is 2. And again, we get 12. So we're pretty certain that we can make 12 groups of 2. Sorry, 12 groups of 7 and get to 84. So I'm going to check it and say, okay, I think I can make 12 groups of 7 and get 84? Well, 7 times 2, that's 14. 7 times 1, 7, plus that 1, 10, that's 8. Oh, yes, if we do make 12 groups of 7, that does give us 84. Now I want to take this same problem and show you that you don't have to do, you don't have to pull, well, it's 10. There's different ways you can break these up. Let's take that same problem of 84 divided by 7 and say, okay, well, I'm dividing it by 7, and maybe you know that all of this area is going to have to equal 84. Well, think about your 7 facts and what are friendly facts. I like 5s. So I know that if I thought about like 7 times 5, that's 35. And that's less than 84. So I know I can take 5 out. That would be 35. Okay. And then I'd have to think, well, if I took 35 out of 84, minus 35, let's see what I have left. Do a little subtraction. 14, 9, 7, 49. Wait a minute, that's a fact too of 7s. If I had to do 49 divided by 7, right? Did I do that math right? 14, 13, 12, 11, 10, 9, that's right. But I had to borrow there, so 7, 49. So I know I have 49 left in there. So I don't even need all that. That's fine. But I do know this fact, and that I can make 7 groups of 7 for 49, right? So I was able to make 5 groups of 7 and 7 groups. Okay, so if I did that, then 7 and 5, well, that is 12, isn't it? And I can do the same thing here. If I want to use my distributive property, what I did is I did 35, divided that into 7, and then I had 49 that I also had to divide by 7 to figure out how many groups of 7 altogether would it take. And so when I did that, I realized, okay, so that's 5. I can make 5 groups of 7 there, and this is 7. And if I add those together, that gives me 12. Okay, so it doesn't have to, when you're doing the distributive property, there's different ways you can break the numbers apart, but no matter what you break them apart with, be it a 35 and a 49 that make 84, or what we did here, where we had a 70 and a 14 made 84. Either way, no matter how you break it apart, as long as they add up to what you started with and you're dividing it by what you're supposed to be dividing it by, you'll get the same answer. Okay? So I just wanted to review that really quickly with you. I know we did that in class too, but in case you need to look back, I hope this video helps you. Thank you.